Chapter 1, Lesson 5, Graph Proportional Relationships. So this is the next lesson in Chapter 1 that we're going to take a look at. On page 45, you'll see what we just reviewed in that quiz, which is a coordinate graph, and it gives you some key vocabulary pieces on a coordinate graph. So if you need to go back and refer what a quadrant is, what an ordered pair is, what your y-axis is, and so on, this is a good place on page 45 to just go back and review. But you did just practice in that quiz, identifying and plotting points. And so hopefully we are ready to go with now graphing proportional relationships. So we're going to go down or next to page 46. So at the very top of page 46, I want to spend a minute just talking about some key pieces to being able to identify a proportional relationship. And so we're going to look at that first paragraph. So at the very top, it says, another way to determine whether two quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line and it goes through the origin, then the quantities are considered proportional. So we just got done in lesson 4 talking about we understand and know that in a table it is proportional or equivalent ratios if you have a unit rate or a pattern going through that table. So now when we get into graphing, we will be able to tell on the graph as well if you have a straight line and it goes through the origin, which is 0. That means it's proportional. So there's going to be right now what we've learned, 2 different ways to identify a proportional relationship. So let's take a look at example 1. Okay, so example 1 says, the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. So there is our unit rate. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane, and explain your reasoning. So step number 1 would be to make a table and find the number of feet walked for 0 through 4 minutes. The table's already been done for you. And since in the story it talked about the sloth moving at a speed of 6 feet per minute, when we look at the table, it makes sense to set it up at starting with 0. Well, in 0 minutes, has the sloth moved any feet? No distance. So 0, 0 right there. After 1 minute, the sloth has moved 6 feet. So at 1, 6 feet. At 2 minutes, the sloth has moved 12 feet. 3 minutes, 18 feet. And 4 minutes, 24 feet. So if you notice, this has a unit rate or a pattern of 6 going through. So remember the way we checked that in the previous lesson was we just looked at those ratios. So I'm just taking these right out of the table and I'm determining if they're equivalent to each other. Okay, so here they all are. So I know 6 over 1 is the same thing as 6 or 6 over 1. I know 12 over 2 also simplified is 6 over 1. 18 over 3 also 6 over 1. And 24 over 4, 6 over 1. So all of these are equivalent ratios, and I see that pattern or that unit rate of 6 going through it. So when I see that instantly in the table, I know this is going to be proportional. So let's now look at how that is displayed on the graph and how you would graph it out. So understand here in the table here, when you look let's go back to the graph actually. So on the graph, notice how it's labeled. So the x-axis here is time in minutes. And the y-axis is your distance in feet. So that means here, the time in the table, again, that's our x-axis. And the distance is our y. And I know that and understand that based on the labels on the graph. I understand what x is and I understand what y is. So I know the graph's already been done for you, but what I want you to see and understand is from this table how these points were plotted. How do I know these coordinate points are on this graph? So think about here, anytime you graph on a coordinate grid, it always is x first and then y. That's your ordered pair every single time. So this first column here, your first ordered pair would be 0, 0. And you'll see that on the graph. There it is plotted. Your next ordered pair is 1, 6, again, x, and then y. So notice on the graph, it goes over 1 minute and up the y-axis to 6, and there's a plotted point. The next coordinate point would be 2 and 12. And so if you see on the graph, you go over to 2 minutes and up to 12 feet. Then you would have 3 and 18 and 4 and 24 as your last two coordinate points. And again, those are plotted on here for you. So notice that this proportional relationship here that has that pattern of 6 is creating this straight line. And it is actually going right through 0, which is called the origin. So remember up top here on the very beginning of this lesson, in this paragraph I underlined and we talked about if the graph of the two quantities is a straight line and it goes through the origin, then it is proportional. Those two quantities are proportional to each other. So we can see it in the table, we've got a pattern, and we can also see it in the graph. We have that straight line. So absolutely, that is considered a proportional relationship. And it tells you that right at the end to sum that story up. So let's take a look at the next one together. Got it, letter A. So James earns $5 an hour babysitting. Right here is our unit rate. So we need to determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane. And explain your reasoning in the work zone. So notice you don't have a table here. And so you actually have to set one up and create one. So we're going to take, best I can, we're going to draw ourselves a table like this. And what I want us to see on the graph that you have labels already. Our x-axis is time in hours, and our y-axis is the amount of money. So I'm going to come over here and label time. That is my x-axis there. And then amount here is my y. So I'm putting my labels in the table based on what I see here in the graph. So let's start at 0. Let's talk about at time 0, James, is he making any money? Well, if no time has passed and he hasn't started babysitting yet, no, he's not making any money. So this would be 0. Now let's go to 1. So at 1 hour, James is making $5 an hour. So at 1 hour, he's making $5. Let's try 2 hours next. So if James works 2 hours, he's making $10. And we'll do one more. At 3 hours, 3 times 5, James is making $15. So here's our table that we're going to use. And we created this based on understanding that it's $5 an hour babysitting. Now, what we want to start seeing is if there's that pattern, and what we want to start seeing is when we graph this over here on the coordinate plane, do we see a straight line? Well, we know based on creating the table that this is going by 5 every time, every hour that's going by 5. So we see the pattern. So we have to assume it's proportional when we see that pattern. So let's start graphing these points. Okay, so your first set of coordinate points is 0, 0. The next set of coordinate points, remember you go X and then Y, so 1, 5. The next set is 2 and 10, and then 3 and 15. So here's all my coordinate points that I'm now going to come over to the graph and plot. So let's see if I can make this work and make it look like it makes sense on the graph. So let's see here, 0, 0. I'm going to plot a point right there. At 1 and 5, so at 1 hour of time, I go to the right, and I'm going to come up, and at 5, again, best I can, about there. I'm probably a little too high. I'm a little too high there. But at 1 and 5, 2 hours over 2 and up 10. And then at 3 hours, 15. 15, right about there. So it's hard to tell. And again, I'm a little off here. I put the dot a little higher than I should have. But what should happen is if you were to connect this with a straight edge ruler, you absolutely would have a straight line. And so it's probably easier for you with your pencil right now as you're graphing on your math book. It's probably a little easier for you to hopefully plot those points a little bit more accurately. Mine's a little tougher with the pen I'm using, but I hope you understand that absolutely these are going to fall in a straight line, and they should, because you have that pattern of $5 going every single time, every hour, $5. And so when you see that, and also notice it's going through 0, it's a proportional relationship. So I'm going to come over here and I'm just going to abbreviate. And that's a little thicker than I wanted. Let's come back here. So it's proportional. I'll abbreviate there. And when it says explain your reasoning, you can explain, I mean, this is showing the work and showing the graph. That's one way to explain. You can also say you understand it's proportional because it has a straight line and goes through the origin. It goes through 0. I'll say origin here. Goes through the origin. It goes through 0. So I'm going to have you try one. So you're going to go to page 40. Go down a few more. Independent practice, 49, I believe it is. And you're going to look at example number 2. Yep, so independent practice, page 49, example number 2. Try this one. The table's already been done for you. So now what you need to make sure of is that table proportional? And then graph it on the graph. And so you're going to pause the video, try it, determine if it's a proportional relationship or not. And then again, after, once you think you have it, you can check your answer by unpausing the video. So let's take a look at number 2. So calories in a fruit cup, it gives you serving size and calories per serving, excuse me. And so notice on the table here, it does skip count. It goes 1 to 3 to 5. And so it doesn't go by ones. It's not 1, 2, 3, 4, 5. But that's okay. You should still be able to take what's in the table here and either start one of 2 ways. You can either take and come over and see if you have a pattern or a unit rate. You can determine that by checking to see if there's equivalent ratios. So I took the 70 calories for 1 serving, the 210 calories for 3 servings, and the 350 calories for 5 servings. And I divided all those out and I simplified. And every single one of those simplified to 70 over 1. So right away, I see in the table that it does have a unit rate and a pattern. And so that also tells me that it should give me a straight line on the graph. So I looked at my coordinate points. Servings is the x-axis, calories is the y, and here's my coordinate points from that. And so I carefully came over here and plotted. The graph itself on the y-axis does skip count a little bit. So it's a little tougher to make sure you're estimating a little bit about where some of these points go. Like at 70, you're trying to get it the best you can where it falls, you think, between 50 and 100. And that can be tough. And so when you plot those 3 points, it might not right away look like it's going to be straight. But if you were truly able to take a ruler, a straight edge, and check by connecting those dots, you would have a straight line. And even if it looked like it was a little off, remember when you check in the table to see if there's a pattern of 70, that unit rate going through, it absolutely is going to be straight. And so the other part too, so I did put proportional and it is going to be a straight line. It will go through the origin. So it's actually going to go through 0. Since it's going by 70 every time, if you think about your first coordinate point being at 1 and 70, well, at 0, 0, right, it would be 0. So 0 calories, 0 servings. And so it would eventually go through that 0, 0, that origin. So I put proportional, straight line, goes through the origin, and you see these equivalent ratios. So we're going to stop here today, and this will end the lesson. If you do have some spare time today, you can go back into BuzzMath and continue to work on the lessons that are in there. See you tomorrow.